This is the solution video for Exam 1, Problem 5. And in this problem we will be basically examining full adders and the way that delays propagate through them. And then in the second part, basically it's going to be asking how do you actually solve full adder problems. And so we'll start with here, and we've got that AND gates have 10 nanoseconds of delay, OR gates have 5, and XORs have 20. 22, yes, 20. And so what we need to do is basically kind of just see how S1, how long it takes for these set of inputs to get to here, and then these set of inputs to get to here, and then these set of inputs to get to here. So to start, we have x1, x2, x3 all available at time 0. So the longest path to some bit is going to be, well, we've got 20 from C into S, and we have 20 plus 20, which is 40 to S. So that comes out to be 40. That's because we want to take the maximum. And then to get from A, B, and C in to C out, we have 10 plus 5 is 15, 20 plus 10 plus 5 is 35, and 10 plus 5 is 15, so the maximum of that is 35. Next up, we want to look at this one. So C in is made first available at 40 nanoseconds. So I'm going to put this 40 little here, and these are both available at 0. So S is made available at either 40 plus 20, which is 60, or 20 plus 20, which is 40. So that's just going to come out to be 60. And then C out is going to be made available at, we have 40, and then 0 and 0, so that's going to be 40 plus 10 plus 5 is 55, 0 plus 10 plus 5 is 15, 20 plus 10 plus 5 is 35, so 40 plus 10 plus 5 is the greatest, so that's 55. Next up, we have this one. So this is now available at, the CN is available at 60, and B is available at 55. So, oh no, sorry. This is still available at 4. No, this is available at 35, sorry. So now this is available at 35. And so 35 plus 20 is 55. So that's one possibility. Or 55 plus 20 plus 20, so that's 95. That's the greater. And then we've got 55 at B. So 55 plus 20 plus 10 plus 5 is 90. So 55 plus 35 is 90. That's the bigger, because 35 plus 15 is just 50. 55 plus 10 plus 5 is 70. So that's the largest amount we can have. So those are my maximum delays, and we have the solutions for this. So we have x1, x2, x3. So that's going to make 1, 0, 0. So 1 plus 0 plus 0 is going to be 0 and 1. And then so we've got 1 coming in, so this is going to be 1 plus 1 plus 1. That means C2 and S2 are going to be both 1s. And now this is receiving a 0 plus 1 plus 1. So it's going to have a carryout of 1 and a sum of 0. And now for part 2, we have 0 plus 1 plus 1. So this, let's just write this one out so you can actually see this a little bit clearer. So 0 plus 1 plus 1. So that's going to make this output 1, 0. And then this 1 is being input into here. This 0 is being input into here. x4 is 1. x5 is 0. So the sum is going to be 0 plus 1 plus 1. So it's going to be 1. And the carryout is going to be 0. So carryout comes out over to here. So we have 1 plus 0 plus 0. So we get sum of 1 carryout of 0.